you don't know. So it's no because there's no evidence of any research having existed on this area. When you are designing a hypothesis, you have no idea what these are. You do not know your results when you are designing a hypothesis. So this is not the justification for your hypothesis. You can't make a hypothesis on the back of your results, so please do not reference results with a justification as to whether it's directional or non-directional. You're asked to write a suitable hypothesis. Odds are this will always be 3 marks. Mark number 1 comes from, is it non-directional? So naturally following on from the previous question, is it non-directional? Is my independent variable operationalized? And then is my dependent variable the same? Now, if my dependent variable and my independent variable are both operationalized, which means I am being specific as to how we are measuring this, and there's no reason not to be, considering it says exactly how they are measuring it here, and I've got a non-directional, that should be your full 3 marks. Identify a suitable graphical display for the data and briefly explain why this was appropriate. A suitable graphical display is a scatter graph. You're looking at a correlation between map reading and driver rating. Because you're looking at a correlation, you're looking for a relationship. A bar chart won't do because it won't show you a relationship. You'll feel it's a relationship, and then it's always a scatter graph. That's how you measure correlations. Please ignore my horrible drawing of a scatter graph. Using the data in table 1, comment on the relationship between the map reading scores and the driver rating scores. So everything you need to know should come from here. All you've got to do is look across and say, okay, 17, 9, 8, 4, 15, 7. The higher your map reading scores, the higher your driver rating. We can see this as every time, often, not every time, often, the higher scores are preceded by higher driver rating. This means often a higher map reading score may result in a higher driver rating, or there is a strong relationship between map reading and driver rating. That's got to be your answer here. So there's a strong relationship between map reading and driver rating scores, because whenever there is a high driver rating score, there is a high, whenever there's a high map reading score, there's a high driver rating score. Briefly outline one problem of using a single trained observer to rate the participants' driving skills and the practical tests. Briefly discuss how this data collection method could be modified. So there's actually a lot going on in this question. So it's asking you to outline one problem. It's asking to outline one problem of using a single trained observer on the participants' driving skills. What's a good driver? A good driver, what that means is subjective. And because it's so subjective, having one observer may allow this observer to have their bias. What they see as a good driving skill may not be the rule of what a good driving skill is. So one problem is this method of rating driving skills is subjective, not objective, subjective. Make sure you know which way around they are. And a single trained observer may bring their bias into the situation. Now that's half our question, so that's 3 marks there. Our second half is Briefly discuss how this data collection method can be modified. Very simply, we're adding observers, and then they discuss it, and then their agreements becomes the results. Now all of that is called inter-observer or inter-relator, rater even. Having a recording of all of my mistakes is going to backfire on me. So you've got your half the marks coming from outlining the problem with a single trained observer. You've got the other half coming from the fact that fixing it involves having more than one observer, discussing it until they reach an agreement, which is inter-observer or rater reliability. Pick observer or relator, it shouldn't matter that much. So the researcher decided to analyze the data using a Spearman's row test. Explain why this is a suitable choice. So I'm going to write my table down. So however it is that works for you to try and remember this, as long as you have a way, whether it's no, Rick, students come class, when Miss says, Rick, you part-timer, or whatever, however you want to remember it works for you, that's fine. See, easily, I don't actually have to look at the research because they've told me it's Spearman's row. So I know it's Spearman's row. So in order for it to be Spearman's row, there's got to be a correlation. And I've got to use ordinal data. But it is 3 marks here. For those 3 marks, I've clearly got to say 3 valuable things. Correlation, ordinal, and then the data is in pairs, or related pairs for those 3 marks. So know your table, that's the important thing, and that's all that matters, knowing your table. After analysis of the data, the researchers obtained a calculated value of 0.808. Using the information in table 2, what conclusions can the researcher draw? Okay. Back at the very start, when we were young and motivated, we decided that the hypothesis should be non-directional. Therefore, it's two-tailed. So remember, we've got our little arrow. If it's one-tailed, we know which way our results are going to go. If we don't know which way, frankly, it could be both ways, and we're stuck in the middle trying to decide. So if it's two-tailed, there are 2 directions to this arrow, and it could go either way, and we have no clue. So naturally, we're going to go for a level of significance that is a two-tailed test. Now, whenever we are not given an explicit level of significance, we go with 0.05 because that's standard. And then have a look back at the number of participants, and we can see clearly we have 9 participants. Meaning that we are looking here, and we are looking here, and our value in the table is 7. So our calculated value, our R, so our calculated value is 0.808, and our critical value is 0.7. Calculated R's must equal or exceed the critical value. This must equal or exceed this. This does equal or exceed this. Therefore, our data is significant at the 0.05 level, meaning there is a 95% chance our results are accurate. Importantly, the question is asking what conclusions can researchers draw about the relationship between map reading and driving skills of the motorist. They're not saying, hey, what's a sign test? They're saying, is it map reading and driving skills, is it significant in this study? So we're saying, yeah, it is. We have to add a little bit more than that. We have to apply it back. So we have to say, therefore, either does have an E or doesn't, but you know what, I'll do them both. Therefore, our data, or therefore, there is a significant correlation between map reading and driving skills. So what does this data mean? With all of this, what does it actually mean now that we know it's significant? We know that there's a 95% chance that this is a good correlation. That is what I have to say. With question 16 then, distinguish between a type 1 and a type 2 error. This was quite an easy question that disappointingly a lot of people struggled with. There are 3 parts to this question. Type 1 is, type 2 is, these are different because. So all you have to say is type 1 is when a researcher accepts their alternative hypothesis and rejects their null even though there is not a relationship. So any relationship they have found is due to chance, you could say. Excuse me. Type 2 is when the researcher says they have not found anything, but the data shows a relationship or a difference. So they have found something, but they say that they haven't, and so what they do is they accept the null. They have not found anything, but they say that they have because, frankly, they are greedy. This is different because one involves accepting the null when they should reject it, and one involves rejecting when they should accept it. Okay, this one, on the whole, quite straightforward. This one was done very poorly. So 17 was a bit of a disappointing one, to be honest. What do the mean and standard deviation values suggest about the male and female performances in the investigation? Once again, I can see 4 marks, 2 things it's asking me. Forget it, I'm treating it as 2 and 2. So I'm going to say mean and standard deviation. The mean shows that clearly males had a considerably higher considerably higher map reading scores than females. I said considerably, not significantly. This is not a stats test. I cannot say this is significantly higher than anything. I have not done a sign test. I do not have the evidence to say that. All I can say is that it is considerably higher. As it's still considerably higher, I have some kind of understanding then that map reading skills are better for males than they are for females. So that's my mean bit done. Essentially, I need to say males have this number, females have this number, males are better in this study than females. How misogynistic. Standard deviation. So if you look at the standard deviations, they're actually quite similar. So standard deviation is what's the spread like in reference to the mean. So if I've got, this is my data here. This is my data, and what I've actually got is this as my data curve. So this is map reading scores, and well, how have I done that? Okay, let's. Okay, so this is map reading, and this is frequency. So this is number of people, and that's map reading. My mean is always going to be somewhere near the top. Now, because it's nice and close together, it shows all of my data is close to the mean. So this number is going to be small. My standard deviation is going to be small because all my data is close to this mean. Alternatively, what I might get is this. My mean is still here, but all of my data is quite far away from my mean. So because it's all quite far away, my standard deviation will be an awful lot higher. Both these numbers are very small. Clearly then, the standard deviation for males and females is very small, which means that the spread within the group is minimal. That's quite a straightforward question. Again, I think, to be honest with you, that should have been one of those slam dunkers. So maybe that's an area to work on in the future. Question 18 then. It was just doing the work on this one, and it was just double checking your scores. So what percentage of the male group scored above the mean? Well, if you look across at the percentage or the numbers who did better, we have 13 out of 20. And then for the females, we've got 5 out of 20. I then need to figure out what percentage is 5 of 20. Well, I already know 5 times 4 is 20, so 5 is 25%. 13, I need to calculate for this one, is 65%. You get a mark for the calculations, mark for the percentage for each one. That's where you get your 4. Using your answer to both 17 and 18, comment on the performance of males and females at this study. The difference in the percentages confirms the earlier suggestion that men are much better at map reading than women. Men have a 65% of people being above the mean. Women only have 25%. It says that most women were below our average. Most men are above our average. And most examiners are very sexist. Briefly explain one reason why it is important for research to be replicated. You did not get the marks unless you wrote somewhere reliable. So it increases the fact that, or it increases reliability. Because the odds of making the same mistake twice two times even is minimal. And then finally, okay, whenever you have a design a study question, read your STEM and then use headings. Your heading number 1 is, so your question here is asking, with reference to the card sorting task, explain how you would ensure that this is made same for all participants. Standardized procedure. So my standardized procedure is, so that's my heading, and then I will talk about a standardized procedure, what I would do, for instance, make sure all the cards are the same, make sure the brand is the same, make sure everyone does it in the same environment, make sure everyone gets the same amount of time, make sure everyone has the same deck in the same order. One methodological issue you should take into account when obtaining suitable participants. Sample. So I've got my heading sample, and then I'll talk about I might get them via a, does it already tell me? Nope. I might get them via a random sample, and an issue with that is some might have experiences beforehand. Explain how you would deal with this issue. I'd exclude the ones who have experience. And then finally, you would ensure that the experience, how would you ensure the experience of your participant ethics? And I already know ethics is in depressed donkeys can't persuade park cars well. Just pick one. Withdraw is the easiest one. Deception is pretty easy as well. So let them withdraw at any point. I would ask for informed consent, and then I would fully debrief them. Okay, I need to go lie down. If at any point you have any questions with that, please do let me know. Anything that you would like to redraft or anything you would like me to reread, please ask. I should again be wandering around, so if anything is sort of questioning you or if I got anything wrong, please ask. Your paper should be full of comments from yourself. So you should have things written all over it as sort of additional ideas and things to add. Can you please make sure you have that and pick the question you are struggling with most? The question you're struggling with most, can you then answer said question? This has been really good. I'm going to go take a nap and ask me if you've got any questions. Thank you very much, guys. Bye-bye.